All right, so in the second half, now that we've kind of done the basics, how we find min and max values, we're going to do actual story problems that connect to finding the minimum or maximum value of something. So looks like a lot of steps. They're all relatively quick, and we've kind of done them already in the first video. So step one is to define your variables. So you'll see exactly what I mean by that when we go and set up this example on the next page. Next, we want to write a system of inequalities. So once we have our variables, we're going to write inequalities that match with the variables we're using and with the context we're talking about. Graph the system of inequalities. Okay, so plot it just like we were doing in the previous video, just like we were doing in section 3.2. Find the coordinates of the vertices. Okay, so just like we were doing up here, find the vertices, label them. Step 5, write a linear function. To be optimized, we either want to maximize a certain value or minimize a certain value. So the linear function would be something like this. And so that, again, will make more sense once we see context with a story problem. 6, substitute the coordinates into the function. Okay, so subbing the vertices into the function is exactly what we're doing with a step like this. And then finally, select the max or min. So depending on what the question is asking, you might want the maximum value, you might want the minimum value. So keep these steps. They're also written very similarly in the book. So let's walk through exactly what we're doing here. So we've got an example on this page. A lot of words, looks like a big paragraph here, but we're going to walk through everything. So a landscaping company has crews who mow lawns and prune shrubbery. Company schedules 1 hour for mowing, 3 hours for pruning. Each crew is scheduled no more than 2 pruning jobs. Each crew schedule is set for a maximum of 9 hours. On average, $40 to mow a lawn, $120 to prune shrubbery. Find a combination of mowing lawns and pruning shrubs that will maximize the income. Okay, so step 1 is to define variables. Okay, so we'll use M for the number of mowing jobs, and we will use P for the number of pruning jobs. So really the last sentence will help you figure out what your variables should be, because it says find a combination of mowing and pruning, so we're trying to find out how many mowing jobs, how many pruning jobs will maximize income. Okay, so that was step 1, define the variables. Step 2, write a system of inequalities. Okay, so let's read through basically sentence by sentence. So the company schedules 1 hour for mowing jobs and 3 hours for pruning jobs. Okay, so 1 hour for mowing jobs plus 3 hours for pruning jobs. They are set for a maximum of 9 hours per day. Okay, so maximum means that the total hours have to be less than or equal to 9. They can't be any more than 9 because 9 is the maximum. Each crew is scheduled for no more than 2 pruning jobs. Okay, scheduled for no more than 2 pruning jobs. So the number of pruning jobs has to be less than or equal to 0. We could also throw in there that it's going to be, less than or equal to 2. We could also throw in that it's going to be greater than 0 because you can't do a negative number of pruning jobs. On average, the charge for mowing a lawn, okay, so we'll bring that in the end. So we've got a couple little details here. Let's see if they mention anything. So each crew, all right, so that ought to do it. So we've got these inequalities that we can graph. So the next step is to graph the system of inequalities. So if we look at this is in standard form, so we'll plot with intercepts. So the m-intercept, if I block this off, would be 9. And the p-intercept, if If I plug in 0 for m, would be 3. Just divide both sides by 3. So let's label this the m-axis. Let's label this the p-axis. First of all, only this region right here even makes any sense to begin with. We can't have negative pruning jobs. We can't have negative mowing jobs. So it's really only the first quadrant that we even care about to begin with. So my m-intercept is 9. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 would be right about there. I'm just going to extend a little bit. And then my p-intercept would be 3. So up 1, 2, 3. Okay, this is a less than or equal to, so I can connect the dots here. Now be very careful. I go down 3 over to the right 9. So down 3 to the right 9, I can reduce that to down 1 over 3, down 1 over 3. That way I can keep everything consistent. Now this is actually going to be a segment because it doesn't make any sense to have negative values. So I'm not going to continue this line below the axes because I told you we're restricting ourselves just to that first quadrant. Okay, so my test value, I can plug in 0, 0. If I plug 0, 0 in here, I get 0 is less than or equal to 9, and that is definitely a true statement. Okay, so what I'm going to do is I'm going to shade everything underneath this line towards the origin, but I'm not going to shade under the axes or to the left of the axes because it doesn't make sense in the context of the problem to have negative values. So next I've got this right here. So pruning jobs are going to be between 0 and 2. So here's my p-axis, here's 0 on the p-axis, and here's 2 on the p-axis. So it has to be somewhere in between those two values. Okay, so here's 0 pruning jobs, here's 2 pruning jobs. Okay, so what it's basically going to do is going to cut off that top part there. So in between 0 and 2, if I shade that, it would look like this. Okay, so my overlapping region, the region that ends up under this line, because the line tells you their maximum hours, and the vertical line tells you how many maximum pruning jobs they're going to have. So we end up with that purple region. Okay, so we are on to step 4, find the coordinates of the vertices. Okay, so the vertices, we've got 0, 0. Okay, so that would be no mowing, no pruning. It technically fits the inequalities, but we know that's not going to make them any money. This one over here, that is the coordinate point 9, 0. That would be 9 mowing jobs, 0 pruning jobs. Again, fits the bill here. They won't be working any more than 9 hours, and they won't be doing more than 2 pruning jobs. This one right here, this is 1, 2, 3, and then 1, 2. This is 3, 2. Okay, so that's 3 mowing, 2 pruning. Fits the bill again. They won't be working more than they should be and not doing more pruning jobs. And then this one right here, that would be the coordinate point 0, 2. Okay, so all 4 of these mark off this purple shaded region that I've got. Oops, everything was kind of off the screen there. There's the 0, 2. So step 5 is to write a linear function to be maximized. So we use f for function. This is a function of m and p, since we didn't use x and y here. So a function of m and p, this is what we're trying to minimize or maximize. So we are trying to maximize the income. So we're going to set up an equation that represents how much money they're going to make. So if we read through here, it says the charge for mowing a lawn is $40. So they are getting $40 per mowing job, combined with $120 per pruning job. Okay, so this represents their income. We're trying to maximize that income, so we move on to step 6. Step 6 is to sub the coordinates into the function. So we've got these different values of m and p that we are going to sub in to this function. Okay, so first vertex is 0, 0. If they don't do any work, they're not going to make any money. We know that. So that's not going to maximize the income, that's for sure. Okay, 9, 0, 9 mowing jobs, 0 pruning jobs. We can plug that in. So 40 times 9 means they're making $360. Not great. Okay, let's plug in 3, 2. So 3 mowing jobs at $40 a pop, and 2 pruning jobs. So this is 120 This gives 240. So that actually also gives 360. Okay, and then the last one is 0.2. If we plug that in, no mowing jobs, but 2 pruning jobs. So $120 each. That is 240. Okay, whoops, dollar sign here. Okay, so if we are trying to maximize income, this actually gives you the exact same value. So to answer the question, there are 2 options. You can either do 9 mowing jobs and no pruning jobs, or 3 mowing jobs and 2 pruning jobs. They'd end up with the exact same income either way. So either one of those outcomes would maximize their income.